Bismillahirrahmanirrahim. Assalamualaikum dear students. I hope you all are fine and in the best conditions of your health. So in today's lecture for the course of medicinal chemistry, we shall discuss about the mechanism of drug action. Right. So the key concepts which we shall discuss in this lecture is we shall see about what do we mean by the term drugs, how drugs produce biological effect, and then we shall see about the mode of action and the mechanism of action. Right. So before going to the topic of our today's lecture, that is the mechanism of action of drugs, let's see what are drugs. So drugs are actually the chemicals that are able to produce a biological effect on your system, on your body. Right, so whenever you take a chemical and that chemical results in some change in your biological system, then this chemical is said to be drug. So one thing for sure is that all things can be drug except your food. So the food you are taking is not considered as drugs. So any chemical except food that can change, that can have positive or negative effect on your body is called a drug. So if a drug has positive effect, this is called a medicine, while if the drug has a negative effect, that's called a poison, right? So in the very start lectures, we saw that the terms of medicine and poison is very flexible, because if a toxin is used in control amount, that can be used to treat a disease. Also, if a medicine is used in uncontrolled amount, that can result in death, right? So the difference in the terms between toxic and medicine is very blurred, right? So since the area is very gray area, so that's why instead of calling a chemical as a drug or as a medicine or poison, we prefer to use the term of drug. Next, in the previous lecture, we also see that the drug is able to show its action only if it is able to get dissolved in the biological system, only if it's able to get absorbed through the cell membrane, and if it's able to interact with a target molecule. Right? So if a drug is able to be absorbed, it's able to be solubilized inside your body, but if a drug is not able to bind with the target, so biological effect will not be produced. So it's not just enough that you are taking a medicine, right? So it's important that the medicine or the chemical you are taking, that should be able to be absorbed, it should be able to be solubilized in your biological system, and it should be able to bind with the target, right? Also in the previous lectures, we have seen that this binding of your target with the receptor, it should be reversible, right? So if a drug binds permanently to a target, then in that case we get some toxic effect, right? Also, if the drug should have great affinity for a particular target, right? So there are many targets inside your human body. So if you are taking a drug, it's important that your drug targets a special molecule, right? So your drug must have a specific target. If your drug does not have a specific target, then in that case the drug can bind to any biological molecule that's present in the body. So just remember that all biological molecules in your body, they are performing certain functions, and if a drug binds to a body molecule which is not supposed to bind, then in that case some undesirable side effect will be produced. So it's very important that your drug should bind with a specific target, and the binding should be reversible, right? So let's continue with our lecture. So in principle, when we are considering that how drugs act, right? So the topic of our discussion is that how drugs act, right? So one thing you must keep in your mind, that drug is not doing something new to your body, right? Drug is not imparting any new function to your system, to your organ, or to your cell. Drug is not doing anything new. So there are many biological systems, there are many biological processes that are occurring in your body. What happens that in a disease state, these biological functions are not occurring at the pace at which they are supposed to occur, right? Suppose that if a certain biochemical reaction was occurring, but because of the disease, that biological action is not occurring because certain enzyme is not working properly, right? So since the enzyme is not working properly, so this reaction is not catalyzed properly, then the drug will do what? The drug will just improve the pace of action of already existing biological process. Right? The drug is not doing anything new. It's doing what? It's just helping the body to keep pace with the biological process that were occurring. Right? So अगर आपको बीमारी हो जाती है देन उस सूरत में क्या होता है, आपकी जो बायोलॉजिकल सिस्टम है, आपकी जो बायोकेमिकल प्रोसेसेस हैं, वो उस स्पीड से काम नहीं कर रहे होते जिस स्पीड से उन्हें काम करना चाहिए. तो ड्रग क्या करती है, सिंपल वही बायोलॉजिकल प्रोसेस जो कि पहले हो रहा था और उसकी अब स्पीड कम हो गई है, तो आपकी जो ड्रग है उसी बायोलॉजिकल प्रोसेस का जो पेस है उसको इम्प्रूव कर देगी. राइट? क्योंकि आपका एंजाइम काम नहीं कर रहा. सो वो जो काम एंजाइम कर रहा था पहले, अब वो काम आपका ड्रग हेल्प करेगी आपकी बॉडी में कि वो कराए. सो ड्रग डज नॉट इम्पार्ट एनीथिंग न्यू. कोई नया काम नहीं करती है. सिर्फ जो आपका प्रोसेस पहले काम नहीं कर रहा था, ड्रग का काम ही ये है कि वो आपकी बॉडी को हेल्प करती है कि वो प्रोसेस जो काम नहीं कर रहा या स्लो काम कर रहा है उसको प्रॉपर तरीके से काम करने में हेल्प कराए. नेक्स्ट वी हैव मोड ऑफ एक्शन ऑफ ड्रग. राइट? सो मोड ऑफ एक्शन ऑफ ड्रग मीन्स द बायोलॉजिकल, the biochemical, the physiological mechanisms by which a chemical produces some response in your living organisms. Right? What happens? The mode of action is the set of biochemical processes or the physiological mechanism. It's not only chemical process, there may be some physiological mechanisms, right, by which any drug can produce some response in your living organisms. Right? So when a drug acts by means of certain mechanism, we get some effect. Right? So we say that we should get some response. So this response is actually what its effect. So whenever your drug acts in the body, what happens? It changes. It doesn't change. It affects certain biochemical process. Right? So effect of the drug on that biochemical process is observed as a response in the living organism. Right? So this is response is the effect which we are able to observe. For example, penicillin is an antibacterial agent, right? It is used to kill bacteria. Now, the penicillin acts actually on the cell wall of the bacteria, right? It actually interferes with the cell wall synthesis of bacteria. You know that bacteria has a cell wall, and that actually if we can just rupture the cell wall, if we can destroy the cell wall, we can easily kill bacteria. But until we break the cell wall or until we stop the synthesis of the cell wall, we cannot do anything to bacteria. Right? So bacteria के बाहर एक cell wall होती है, और अगर आपने bacteria को ख़त्म करना है तो लाजमी ये कि आप cell wall को तोड़ दें. Okay, you must interfere with the cell wall synthesis. आपको या तो cell wall बनने नहीं देनी है या आपने उस cell wall को rupture कर देना, break कर देना. पेनिसिलिन क्या करती है? पेनिसिलिन आपकी जो बैक्टीरिया है उसके सेल वॉल की सिंथेसिस को स्टॉप करवा देती है. राइट? अब दिस इंटरफेरेंस इन सेल वॉल सिंथेसिस इज कॉल्ड एक्शन ऑफ द पेनिसिलिन. पेनिसिलिन ये एक्ट कर रही है और आपका रिस्पॉन्स क्या आ रहा है, आपका इफेक्ट क्या आ रहा है? बैक्टीरिया की डेथ. राइट? सो दिस इज द मोड ऑफ एक्शन ऑफ पेनिसिलिन एंड द इफेक्ट ऑफ and the response as a result is the death of bacteria. Right? So you must have clear concept about the action and the effect. So the way by which a drug acts is called the action of drug, while the response as a result of action of drug is called effect. Right? So when your drug is acting in your body, right? So the way the drug is acting, whether it is interfering in the cell wall synthesis of a bacteria or it is occurring in some other way, right? So the way by which a drug acts, the mechanism by which a drug acts is called the action of drug or the mode of action of drug, and the response as a result, the observable consequence of this drug action is called the effect of the drug. So the problem in pharmacology is that no drug produces some single effect. So you have taken a drug, right? The drug is supposed to do some task, right? You want the drug to have some desired effect, right? So this desired therapeutic effect of the drug is called the primary effect, right? The drug effect which is desired from our side. So this desired effect is called the primary effect, while all other effect beside this primary effect is called secondary effect, right? So if you want to kill a bacteria, this is primary effect, right? You want the bacteria to be killed. This is primary effect of the drug. But along with killing bacteria, if your drug is doing something else as well, right? The effect other than the primary effect is called the secondary effect, right? So secondary effect can be beneficial, but the secondary effect can be harmful. So it's very important for you to know what's the difference between primary effect and secondary effect. So if we always desire that our drug only produces primary effect, we are not interested in secondary effect, whether that's beneficial or whether that's harmful. We just want our drug to act in a single way, right? So we always want a drug to act in a single way. We don't like any secondary effect. We are not interested in secondary effect, whether the effect is beneficial or whether the effect is harmful, right? So whenever you are considering about drug design, when you are considering about the drug receptor interactions, just keep in mind that we want our drug to act in a single specific way. We do not want our drug to act in many ways. It should be very, very specific in its action, right? So what we have seen so far, that the mode of action of a drug means the way by which a drug acts, right? So as a result of this mode of action of drug, as a result of this action of a drug, we get some observable response, and this observable response is called the effect of the drug, right? So action of the drug is the way by which the drug is acting, and as a result of this action we get some response, and that response is called the effect, right? So effect may be primary and effect may be secondary. So primary effect means the desired effect, while the secondary effect means in addition to the desired effect, what we are getting is the secondary effect, right? So secondary effect may be beneficial or the secondary effect may be harmful. The next is the mechanism of drug action. So the terms of mode of drug action and the mechanism of drug action, they are very quite similar and often cause confusion. So in most of the times we don't differentiate between the mechanism of action of drug and the mode of action of drug. Right? So most of the times we don't differentiate between these two terms. We don't differentiate about the mechanism of action of drug or the mode of action of drug. So in general, the mechanism of drug action is a combined study of determination of site of action and the general nature of drug receptor interaction. Right? So when we say that we are studying the mechanism of action, so mechanism of action involves the study of where the drug is acting and how the drug is acting, right? So when we say mode of action means drug is doing this, right? We are not saying about drug is doing this at this place and this way, right? So mode of action is simply how the drug is acting. But when we say the mechanism of drug action, so mechanism of drug action is a very vast term, and the mechanism of action is a combined study of determination of the site of action, means where the drug is acting, and it's also the study of general interaction of drug receptor interactions, how your drug is acting on the receptor, how your drug is interacting with your target molecule. Right, so this is the difference between mechanism of drug action and the mode of drug action, right? So mode of drug action is simply means that how the drug is acting. But when you say mechanism means you should study about where the drug is acting and what is the general nature of this drug target interactions. So when we say mechanism of drug action in general, most of the drugs act in 4 ways, right? So drugs either act by means of killing foreign organisms, right? For example, the chemotherapeutic agents act by killing or weakening foreign organisms. For example, bacteria, worms, or viruses, right? So this is mechanism of drug, that your drug is actually killing the microorganisms or the foreign organisms, or they can even weak the foreign organisms, right? So when we say that the mechanism of action of drug is killing foreign organism, means the drug is acting by means of killing the foreign organism. For that case, it's important that your drug must be selectively toxic, right? Because you are going to kill a cell. The bacteria, the worms, the viruses, they are living organisms, and these are composed of the living matter, right? Similarly, the human cells or the cell of any living organisms, they're also made up of the same material, right? So when your drug is going to kill a bacteria or a worm or a virus, it's important that your drug should not harmful to the host. Host means the organism which is the target of that microorganism, right? So in case if you are considering a drug to act on a human, that's very important that the drug must be toxic only to bacteria or worm or virus, but it's not toxic for humans, right? Because the chemicals that are present in the bacteria or the worm or the virus, these chemicals or similar chemicals also present inside your body, right? So this is principle of selective toxicity. So whenever a drug is acting by means of killing foreign organisms, so the drug must be selectively toxic. It should be only toxic to the parasite. It should not be toxic to the host, right? So this is very important parameter which should be considered when you are considering the drugs that act by means of killing microorganisms. The second mechanism of action by which the drugs act is the stimulation or depressant, right? So drugs act by stimulating or depressing normal physiological function, right? So there are many biological processes that are going on in your body, right? So one of the mechanism of action of drug is that your drug acts by either stimulating a certain biological process or depressing a certain biological process, right? For example, when say stimulation means the increase in rate of activity, while depression means the reduction in rate of activity, right? For example, so if a person is going through very severe cancer, right? If a person has cancer, so in cancer what happens, that inflammation increases, right? So you want to reduce that inflammation. What you will do to reduce the inflammation is that you will depress the process that is causing inflammation, right? So inflammation is actually a biological process. Drug is not doing something new. Drug is doing what? Drug is reducing the rate of inflammation. Why? Because we want to help the person to overcome the pain, right? So this is a process in which we are going to depress the system. How this is going to depress the system? Because your drug will interfere with an enzyme. See, the mechanism of action means the site of action and the drug receptor interaction as well. So your drug will do what? Your drug will interact with the enzyme that is responsible for causing inflammation, right? And your drug will suppress that enzyme, right? So in this way the drug is acting to suppress or depress a biological system, a biological process. Similarly, you might have observed that when you have to stay awake for longer at night, you take caffeine, you take tea or coffee. So you say that your brain becomes active when you take tea or when you take coffee, because the caffeine in the tea or the coffee, that is the stimulant, it activates your nervous system, right? And in case if someone is feeling very high amount of pain, what we do is that we give them painkillers. And what these painkillers are doing, these painkillers are suppressing central nervous system, right? So these painkillers are suppressing central nervous system so that your brain is unable to detect the feeling of pain, right? So it's not stopping pain. The CNS depressant you are taking is not stopping pain. It's actually causing your brain not to sense the feeling of pain, right? So this is called stimulation and suppression, right? So अगर आपकी बॉडी के अंदर एक प्रोसेस जा रहा है लेकिन आप चाह रहे हैं कि वो प्रोसेस ना हो, तो हम क्या करते हैं कि जो चीज़ उस प्रोसेस के लिए रिस्पॉन्सिबल होती है, हम उस प्रोसेस को सप्रेस करवा देते हैं. अगर इन्फ्लेमेशन के लिए एंजाइम रिस्पॉन्सिबल है, आप चाहते हैं इन्फ्लेमेशन ख़त्म हो जाए, तो हम क्या करेंगे, हम उस एंजाइम को सप्रेस कर देंगे. सिमिलरली अगर आप चाहते हैं कि एक प्रोसेस ज़्यादा से ज़्यादा हो, आप उसे एक्टिवेट करना चाह रहे हैं, जैसे आप रात को देर तक जागते हैं, आप चाहते हैं कि आपका दिमाग एक्टिव रहे, आप चाय लेते हैं या कॉफ़ी लेते हैं, उसकी वजह क्या है कि चाय या कॉफ़ी आपके दिमाग को एक्टिवेट कर देगी, आपके दिमाग को स्टिमुलेट कर देगी. और जो पेन किलर्स हैं वो क्या करते हैं, आपके सेंट्रल नर्वस सिस्टम को, आपके दिमाग को वो फीलिंग ऑफ पेन नहीं आने देते. सो पेन वहीं होती है, तकलीफ वहीं होती है, बट आपका दिमाग चूँकि उसे सेंस नहीं कर रहा होता, इसलिए आपको फीलिंग ऑफ पेन नहीं आती. राइट, सो दिस इज पेन किलर. Right, so they are all painkillers are CNS depressant because they depress the CNS of your system. Right. The third mechanism of action is irritation. Right. So irritation is a non-specific action of a drug. Means irritation can occur anywhere. It's not specific for a certain biological part of body. Right. So irritation can occur at any place, at any part of your body. So certain drugs act by causing irritation, for example, senna and castor oil. So they have laxative effect, right? So they have laxative effect by means of their irritating action on the GIT tract. So if a person is having some constipation and the constipation is becoming very, very severe, in that case we advise the person to take castor oil, right? So if a person has constipation and if he takes castor oil, what happens that castor oil has a laxative effect, right? So how laxative effect occurs? The laxative effect occurs by irritation of your intestine, right? So this castor oil irritates the large intestine. So as a result of this irritation, the large intestine moves at a larger frequency, resulting in elevation of the constipation, right? So this is a mechanism by which we use irritation. Then certain drugs act by means of replacement, right? So drugs act as replacement for essential body chemicals that are either absent or they are present in less amount than is required. For example, if a person has diabetes, then you know that the diabetes is caused by reduced level of insulin, right? So if a person is diabetic, he has either no insulin is being produced by the pancreas or the insulin is produced in a very less amount. So what happens that we give insulin externally, right? So what we do is that we give insulin externally. So we are we are providing a replacement for a chemical, right? Because your body is not able to produce insulin or insulin is produced in very less amount. What we do is that we give insulin externally, right? So in this way, this is a type of replacement. Similarly, the use of Levodopa. So Levodopa is basically given in case of Parkinson's disease, right? So in case of Parkinson's disease, your body is unable to produce the dopa isomer. As a result of that, the brain is unable to function properly. So what happens that in Parkinson's disease, if some person is suffering from Parkinson's disease, what we do is that we give him or her Levodopa, right? Because the Levodopa is not being produced in your body, or it's produced in less amount, right? So giving the external amount of Levodopa helps the body to overcome the deficiency of that chemical. So these were the 4 ways by which drugs can act. So drug can act by means of killing a microorganism, drug can act by means of stimulation or depressant, a drug can act by means of irritation, or drug can act by means of replacement, right? So now we just go to various properties that are responsible for biological action, right? So drugs act, right? So why a drug is able to kill a microorganism, how a drug is able to suppress the central nervous system, or how a drug is able to cause irritation. So whatever the process a drug is doing, so this process the drug is doing is dependent on the physical and chemical properties of a drug, right? So whatever the drug is doing, whether the drug is killing a microorganism or the drug is causing some irritation, right? So all of these processes, they are because of certain physical, chemical or biological property of a drug, right? So the fundamental mechanisms can be distinguished into 4 categories, right? So drug can show a mechanism of action because of its physical properties, or a drug can show mechanism of action because of its chemical properties, or it can show its biological action through interaction with biological target. Right. So physical properties are responsible for drug action. For example, you know that all things that are bitter in taste, they cause acidity, all drugs, all chemicals that have a bitter taste, they increase the HCl reflux in the stomach. For example, Quassia, Chirata. So both of these drugs, they have bitter taste and they increase the acid reflux. Right? So this is the physical property. So taste is a physical property, and this taste is causing some biological effect. Right? The taste is bitter, it's a physical property, and the biological effect is what? The increase in HCl reflux. Similarly, drugs that have high molecular weight, they have laxative effect. So whenever you are going to make a drug that is laxative, then what you do, you must have a high molecular weight, right? So mass is a physical property, and the effect is what? Effect is biological action, right? So whenever you are going to make some laxative effect, drug with laxative effect, you must increase the molecular weight of the drug. For example, Isapgol. So Isapgol is basically a naturally occurring resin. It has high molecular weight, and you know that Isapgol is actually very useful as a laxative agent. Then we have adsorption. So adsorption is a physical property, right? And by means of absorption, we can remove heavy metals from your body, right? So certain drugs like kaolin, they absorb water onto the surface, right, and reduce gastric motility. So adsorption can be used for removal of heavy metals, and adsorption can also be used in case of diarrhea, right? So when you have diarrhea, what is that? Your body is eliminating excessive fluid in the form of feces, right? So when you want to stop the loose motion, when you want to stop the diarrhea, what we do is that we make certain drugs like kaolin. So what happens is kaolin absorbs water from your feces. So because of absorption of water from the feces become hard and the loose motion is stopped, right? So by means of adsorption, the gastric motility, that's loose motion of the diarrhea, that can be treated, right? So adsorption is a physical process, and the biological response is reduced gastric motility. Similarly, adsorption can also be used for removal of heavy metal toxicity. Then we have radioactivity, right? So radioactivity is a physical process, and this radioactivity is used to treat cancer, right? You can see that how the physical properties can be utilized for treating a certain biological process, right? Then we have chemical properties. So the drugs that act extracellular means the drugs that act outside the cell, right? So drugs that act outside the cell, they act by means of simple chemical reactions, right? So either drugs act by means of neutralization, or they act by means of chelation, or they act by means of oxidation, right? For example, when you have high amount of acidity, right? When you are having acidity, what you take milk of magnesia, or you take aluminum hydroxide, right? So aluminum hydroxide or the milk of magnesia, they are basic in nature. What they do is that they simply neutralize the acid in the stomach, right? This is simple acid-base reaction. This is neutralization reaction, right? Since the process is acting outside the cell, so this is a neutralization reaction. Similarly, if you have heavy metals inside your body, so you can make use of chelating agents like Irritation, penicillin, right? So all of these drugs do what? They just bind with the heavy metals, form a chelate, and get them eliminated from your body. So chelation is a chemical property, and by means of chelation you can eliminate heavy metals. Then we have oxidizing agents. So drug can act as an oxidizing agent, and whenever a foreign organism is attacking your body, whenever a germ is attacking your body, the drugs just oxidize. Drugs act as oxidizing agent and kill the microorganisms, right? So all things that are oxidizing in nature, they are germicidal. Then we have mechanism of action through biological targets. And you know that biological targets are basically the biomolecules that are present inside your body, right? So biomolecules may be enzymes, they may be DNA, or the nucleic acids, they can be proteins, right? So there are basically four type of functional proteins, right? Since proteins are most important targets, so we'll consider about the proteins as the targets. We'll not consider the DNA or the other macromolecules, right? So when you're considering proteins as targets, so there are four categories of functional proteins. Right? Functional proteins are the proteins that are responsible for certain biological processes, right? So there are 4 types of functional proteins: enzymes, ion channels, transporter proteins, and receptor proteins, right? So your drugs can act on all of these 4 types of targets. Drug can act on enzyme, drug can act on ion channel, drug can act on transporter proteins, or drug can act on receptor proteins, right? So here we will see about only the enzymes and the receptor proteins, because they are the most important functional proteins, right? So the enzymes are biological catalyst. So drugs that act on enzyme, they act either by stimulating the enzyme, or they act by means of inhibiting the enzyme. So what we mean by stimulating enzymes means the drugs that act by increasing the production of enzyme. And inhibition means the drugs that act by stopping the enzyme action, right? So drugs can act either way. The drugs can stimulate the protein, the drug can stimulate the enzyme, or they can inhibit the enzyme, right? The stimulation of enzymes increases the affinity of your drug with the enzyme, and that results in lowering the activation of a particular reaction, right? So what happens that when you are stimulating enzymes, overall what you are doing is you are lowering the activation energy for a particular biochemical reaction, right? So as a result of lowering the energy of a particular biochemical reaction, the rate of that reaction will increase. And the enzymes that the drugs that cause enzyme inhibition, right? So they can act by means of non-specific or specific inhibition, right? So if a drug is only inhibiting a particular enzyme, a specific enzyme, this inhibition is called specific. But if a drug is causing non-specific inhibition of all types of enzymes, this is called non-specific inhibition, right? So always remember that whenever you are going for enzyme inhibition, it should be specific enzyme inhibition. Furthermore, the enzyme inhibition can be competitive or non-competitive, right? So when you say competitive enzyme inhibition, it means that your drug and your substrate, they are both competing for the same active site, right? So when 2 things are competing for the same active site, it's called competitive inhibition. But if one of your molecule, if your drug is binding to a allosteric site instead of the orthosteric site, when your drug is binding to the allosteric site, then this case is of non-competitive inhibition, right? So enzymes inhibition can be specific, non-specific, can be competitive or non-competitive. So when you are considering the mechanism of action, it's very important for you to understand and study whether the inhibition is specific or non-specific, or whether the inhibition is competitive or non-competitive. Right? So since enzymes are very important targets, and why they are important targets, because they are controlling almost all biological reactions, right? So these are very important targets of drugs, right? So drugs can either increase or decrease enzymatic reactions. For example, adrenaline, right? It stimulates enzyme known as adenyl cyclase. Pyridoxine acts by increasing the decarboxylase activity. So decarboxylase is basically an enzyme, so it's stimulating the enzyme. Then we have allopurinol. So allopurinol is a drug, and it competes with hypoxanthine for xanthine oxidase, right? You see, this is competition. So this inhibition is competitive inhibition, right? So when we say this competes with that, it means this is competitive inhibition, right? So this allopurinol is a drug, and it's competing with hypoxanthine for enzyme known as xanthine oxidase. Similarly, we have physostigmine and neostigmine, and they compete with acetylcholine for cholinesterase. So cholinesterase is a drug, it is an enzyme, and the drugs are the physostigmine and stigmine or neostigmine. So both of these are drugs, and these drugs are competing with acetylcholine, right? So that's again a case of competitive inhibition, right? So you should know about competitive inhibition, specific or non-specific inhibition. Now we have mechanism of action through receptors. So a large number of drugs, they act through specific target molecules known as the receptors. Right? So receptors are present on the cell membrane, and some receptors are also present inside the cell, right? So in general, whenever your drug has to bind with the receptor, so the drug receptor interaction should be reversible, right? And drug must have high affinity for a particular receptor as well. So if a drug has high affinity for a number of receptors, in that case you get a large number of side effects or secondary effects which is not desired, right? So this is the mechanism of action of drug. So in this case we studied about the mode of action. So mode of action is the way a drug is acting. But when we say mechanism of action, so mechanism of action is a much detailed study. So in mechanism of action we study where the drug is acting and how the drug is acting, right? So we have basically the mechanism of action because of the physical property, because of chemical property, or through some target molecule, right? The target molecule can be enzyme, it can be receptor, it can be ion channel, or some transport protein, but here we have considered only two targets, that's the enzymes and the receptors. I hope that you have understood this lecture well, so thanks for your patience.